All right, let's see what we got here. So I didn't do yesterday's one because I looked at the hard one and I didn't get an answer or didn't apply myself enough to get an answer. All right, anyways, today number of zero filled subarrays medium given an integer array nums return the number of subarrays filled with 0. Number of subarrays filled with 0. Subarray is contiguous non-empty sequence of elements within an array. So I guess number arrays. Oh, it has to be completely filled with zeros. So 0. So there's 1, 2, 3, and then 4, 5, 6. Okay, yeah. So really, it's gonna be for every sequence of zeros, the number of subarrays that can be created with that number of zeros is it's the quadratic n times n plus 1 over 2. So if there's 2 streak of zeros, then it's 2 times 3 divided no, sorry, it's n times n minus 1 over 2. So 2 times 1 divided by, wait, 2 times 3 divided, okay, n times n plus 1 over 2. Yeah, 2 times 3 plus 2 times 3 over 2. And then if it's 3, then it should be 3 times 4 divided by 2, which is 6. 6 plus 3 here is going to be 9. Okay, so I just need to know like the streaks of zeros, and for each streak of zeros, so the number, so key point is a streak of zeros in the array will so let's say there's x zeros, or yeah, a streak of x zeros in the array will have x times x plus 1 over 2 subarrays, possibly, or possible subarrays. And that's the basic formula. So like for instance, if there's like 0, 0, 0, 0, so that means there's 4 zeros, which means that there's going to be 4 times 5 divided by 2, which is equal to 10 subarrays of zeros. And you can, it's the basic, like, there's one subarray that's 4 length, 2 subarrays that's 3 length, 3 subarrays that's 4 length, and 4 subarrays that's 1 length if you were to kind of break it out. So that's equal to 10. And this is basic. This is the very, very common. What's the title of this? Like it's not geometric sum. It's a very common series sum formula for 1 to 1 plus 2 plus dot 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 n. This n over n times n plus 1 over 2. So here I just need to count streaks of zeros, basically. So let's say answer 0 for every value in the nums array. I'll say the current streak is 0, and the previous value is, let's say, -1. I think maybe I can do something like, if the value doesn't equal 0, then I can break the current streak, or let's say the value is equal 0. If the value is 0, then the streak increases. And I'm going to change how this logic is presented, but otherwise this ends the current streak of zeros because you're seeing a value that's not 0. So otherwise you say answer plus equals whatever the current streak is and then reset the streak to 0. So as the streak starts at 0, it sees 1, and I guess maybe I can else if the streak isn't a 0 here, then I can do this jazz. Okay, so if it goes through the values of the array, if it doesn't see 0, then it's going to and it doesn't see 0 and the streak of zeros is not 0, then whatever the current streak is, let's say the current streak is 3, then so it's going to go like streak is 0, streak becomes 1, streak becomes 2, streak becomes 3, and it sees a 2, the value is not 0, so it's going to break the streak. And because the streak is not just 0, 0 so far, then it's going to increment the answer by the number of streaks created by that streak of zeros, and then reset the streak to 0. Streak being the count of consecutive zeros seen. And then lastly, once you finish the array, there could be an ending streak of 0, so you need to do one last incrementing by whatever subarrays are formed by the last streak. Okay. This is by far one of the easier mediums I've seen. I guess you just need to know the formula and how to go from that formula to how it applies to this subarray deal. Okay, but summary. Actually, is there any way to improve this logic? The value is equal to 0, increment the streak. You don't want to do this every time. And it's probably worth it to do a check rather than just to reset the streak and increment it. Yeah, worth it to do this check. And you go through for each loop of values. So I guess the summary here. So apply the apply the above key point to the array by iterating over values, having while keeping track of the current streak of consecutive zeros when at each value. If the value is 0, then increment the streak. If not 0, then reset streak and increment the answer counter by the number of subarrays formed from that length of consecutive zeros. I think there were other ways of doing this that were more computationally intensive, I guess. Like you could say that here If it's a 0, you keep track of the last index of the last 0, and the number of, and keep track of the last 0. And if the current value is 0, then you increase the answer by the difference between the current index and the last index of 0. So you see this 0, then you increase the answer by 1, increase the answer by 2, increase the answer by 3. So that gives you 1 plus 2 plus 3, which is 6. Then increase the answer by 1, increase the answer by 2. That's more of a sliding windowed approach, I think, which gives you the same answer, but it's slightly more computation because it's more of a direct formula that only occurs when you have like the end of the window, I guess. If they're not 0, then reset streak. Okay, yeah. Lastly, since a streak of zeros at the end of the array isn't counted in the loop, do final addition post loop. This is kind of like an example of the kind of fence post issue. All right, time complexity. This can be O of n to iterate over every value in the array and doing constant work. And H. And then space complexity, this can be O of 1 as no additional kind of data structure is needed. Okay, cool.